different strings of rubber of different length produces different sounds because of having different frequencies. And as we know that frequencies depends on lengths. To explore sound in further detail, stick around and watch the video till the end. Let us first define sound. Sensation of hearing produced by vibrating body which travel through medium is called sound. Or we can say that sound waves are mechanical waves, that is, they require material medium for their propagation, that is, they cannot travel through vacuum. Material medium may be solid, liquid or gas. Sound is energy which travels from one point to another with the help of a material medium. Sound can also be defined as that these are the longitudinal waves produced by vibrating body which travel through medium in the form of successive compressions and refractions. Longitudinal waves are those waves in which particles of the medium vibrate in the direction of the wave. Suppose that these are the particles which are vibrating here and there, and the wave is also traveling in this direction. Such wave is called longitudinal wave. Now, what is meant by compression? Compression is the region of high pressure. For instance, these are the layers of air which are compressed because of the high pressure. Contrary to compression, there is rarefaction, which is the region of low pressure. And now you can see the same layers, they are relaxed. That is the distance between the layers that is larger as compared to here. So it is known as rarefaction. There are three important elements for sound waves. That is, there should be some source of vibration, for example the tuning fork. There should be a medium, it may be gas, liquid or solid, and there should be hearing aid, for example ear or sound sensor. Now in laboratory, tuning fork is the source of sound. Tuning fork is an instrument that has been struck with some object, for example rubber pad. It vibrates, thus produces sound of certain frequency. In the figure, this is tuning fork and a rubber pad. So this is a rubber pad, a tuning fork, prongs of tuning fork, and this 256 shows the frequency of this specific tuning fork. Now let us watch a video clip which shows vibrating tuning fork, and to show that the prongs of tuning fork, when vibrating, they transmit energy to other objects. It's a 256 Hz tuning fork. Let's hear its sound. Let me play it again. So you see the prongs are vibrating. Yeah, to prove it that they are vibrating, you can see here as well. Yeah, and it's okay. And if I take another larger frequency, it's 512. So more splashes. And let's take this one. This one is 384. The second major element for sound waves to travel is the medium. Medium may be gas, for example air. It may be liquid, for example water. It may be solid, for example iron. Now the speed of sound in different media is different. For example, in solids it is 5000 meters per second, which is the largest. In liquids it is 1500 meters per second, while in gases it is 300 meters per second. Why the speed of sound is largest in solids? Because the particles of solids are very close to each other and they pass on the sound energy very easily from one particle to another. That is the reason of the largest speed of sound in solids. Now the third element is the hearing aid. Hearing aid may be sound sensor or it may be human ear. Generally, human ear has three parts: the outer ear, which collects the sounds, the middle ear, in which there is an eardrum, and the eardrum receives the sound and it oscillates. Sound waves are transferred from middle ear to inner ear through the vibrating bones, which causes nerves to transmit their sound to the brain. And in this way, the brain receives the sounds and we interpret it. Characteristics of sound. In nature, we have different sounds. Some sounds are faint, some are loud, some are shrill, some are grave. How we distinguish them from each other? This capability is given by God to us through characteristics of sound, in which number first is loudness, number second is pitch, number third is quality. Loudness is the 8 characteristics by which we distinguish loud sound from faint sound. Let's watch video clips and to decide which sound is loud and which one is faint.
Hello, 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 hello,
Hello, hello, hello, hello, hello, hello. Factors affecting loudness of sound. There are 3 factors. Number 1 is area of vibrating body. Larger the area of vibrating body, louder will be the sound, and vice versa. For example, the sound produced by dole is louder than the sound produced by dholak. The second is amplitude of vibration. The larger the amplitude of vibration, the louder will be the sound, and vice versa. For example, if you take a steel plate and you hit it with a steel spoon, when you hit it gently, it produces sound. By hitting it hard, the louder the sound will be. And if you hit it slow, the sound will be faint. So when you hit it hard, what happens? The membrane of the steel plate vibrates to larger amplitude and the sound is louder. Distance from source. If you are hearing sound from nearby, it will be louder. But if you go away, far away from it, then the sound will become fainter. Second characteristics of sound is pitch. Pitch distinguishes shrill sound from grave sound. Pitch of sound depends on frequency. The greater the frequency of sound, the larger will be the pitch, and vice versa. High frequency note is shrill and low frequency is grave. Now let's watch a video in which the frequency of sounds are varied and you will hear sound produced according to the frequency, in which some sounds will be grave and some other will be shrill. So let's watch the video. Third characteristics of sound is quality or timbre. It distinguishes sounds played together and with the same amplitude. That is, if there are 2 similar kind musical instruments and they are played together with the same amplitude, even you can distinguish them from each other. Quality of sound depends on waveform. That is, each instrument when played has its different waveform, which distinguishes this unique sound from other sound. Quality enables us to distinguish between 2 different instruments of the same category. For example, oboe and clarinet, as shown in the figure Both are mostly made up of wood, and both are in the shape of a tube, and in both the air is blown, but still you can distinguish between them. That is, you can distinguish between the sound produced by each of these musical instruments. This is because of the quality of sound. Let's hear the sounds produced by both of them.